Hello everyone. Today we are going to discuss one of the most important topics in enterprise AI, how to build AI agents securely from day one. As organizations rapidly adopt autonomous AI agents, security can no longer be an afterthought. Unlike traditional applications, AI agents make decisions, invoke tools, access enterprise data, and communicate with external systems autonomously. That fundamentally changes our security model. In this session, we'll walk through the security challenges through or challenges unique to AI agents and introduce a practical six-layer reference architecture built on Google Cloud that enables organizations to build secure, production-ready agentic applications. Before we begin, a quick introduction. I'm Jitendra Gupta, a Google developer expert specializing in Google Cloud and enterprise AI architectures. I'm also an author, technical blogger, international speaker, and mentor, where I regularly help organizations modernize cloud platforms and build enterprise grade AI solutions. One of the concepts, or most of the concepts you'll see today, are inspired by real world enterprise implementations and security best practices for production AI systems. Let's begin by understanding why traditional application security is insufficient. Traditional applications follow deterministic workflows. The developer defines exactly what happens. Request A lead to step B and then step C. The execution path is predictable. AI agents behave completely differently. Instead of following fixed instructions, they reason using large language models. They dynamically decide which APIs to call, which tools to invoke, what information to retrieve, and sometimes even create new execution plans. That means the attack surface becomes much larger. Instead of protecting API or only APIs and networks, we must now protect prompts, reasoning chains, external tools, memory, RAG pipelines, and autonomous decision making. This shift requires an entirely new security paradigm. Let's look at the major attack categories affecting AI agents. The first is prompt injection, where attackers manipulate the model using carefully crafted instructions. Second is the confused depth problem. Here, an AI agent may possess higher privileges than the user and unknowingly execute unauthorized actions. Third is data exfiltration. An over-permissioned agent may accidentally expose confidential enterprise information through tool calls. Finally, there is supply chain risk, where insecure SDKs, external plugins, or compromised models become bottle or act, become attack vectors. These threats doesn't exist independently. They often combine together, making layered security absolutely essential. The foundation of our architecture is zero trust. Zero trust follows one simple principle: never trust, always verify. For AI agents, this becomes even more important. We assume that prompts can be malicious, we assume models can be manipulated, and we assume identities may be compromised. This architecture is built around three principles. First, assume breach. Second, verify every request explicitly. And third, minimize blast radius through various or through micro segmentation. Every tool invocation, every API call, every database query should require independent authorization. Security becomes continuous rather than one time authentication. The first security layer focuses on identity. Every AI agent should operate using its own dedicated service account. Avoid sharing identities across multiple agents. Next, use workload identity federation instead of long-lived service account keys. This eliminates static credentials entirely. Finally, apply principal access boundaries to enforce the maximum permissions an agent can ever receive. Even if someone accidentally grants broader IAM permissions, principal access boundaries act as a final safety net. Identity should always represent the smallest possible blast radius. Identity alone isn't enough. We also need network isolation. Google Cloud's VPC service controls create security parameters or perimeters around sensitive services like Vertex AI, BigQuery, and cloud storage. Imagine an attacker successfully compromises an AI agent. Without network controls, that agent might transmit sensitive data to external systems. With VPC service controls, outbound communication is blocked by policy. So even when identity controls fail, the network perimeter prevents data exfiltration. And this is defense in depth. The third layer protects the execution environment. AI agents often execute code dynamically that introduces significant risk. Google Cloud offers gvisor sandboxing, which isolates workloads at the kernel level. Next, harden your orchestration framework. Disable unnecessary tools, restrict file system access, validate all dynamic inputs, and lock down SDK configurations. Finally, introduce human in the loop approval. Human risk operations such as infrastructure modifications or production deployments should always require human authorization. Autonomy should never replace accountability. Security starts long before deployment. Every AI agent should pass through a secure software supply chain. Begin with provenance and artifact attestation. Ensure every container image is cryptographically verifiable and then perform automated vulnerability scanning across dependencies, base images, and SDKs. Finally, enforce binary authorization. Only trusted signed container images should ever reach production. This prevents attackers from introducing modified or malicious workloads into your Kubernetes clusters or cloud run environments. One of the most unique security layer for AI systems is prompt protection. Every incoming prompt should pass through Google Cloud Model Armor. The first stage detects jailbreak attempts. The second removes personally identifiable information and sensitive enterprise secrets. The third filters the third filters unsafe or toxic content. Only after these validation stages or only after these Validation stage is does the sanitized request reach the foundation model? Similarly, responses should also be inspected before returning them to users. Prompt security must operate in both directions. Most enterprise AI agents use RAG, retrieval augmented generation. That means protecting grounding data becomes critical. Implement row level and the column level security in BigQuery. Encrypt all cloud storage or the storage using custom managed encryption keys. Restrict access to RAG documents with least privilege. Even if an AI agent retrieves information, it should only access data specifically authorized for that identity. The model is only as secure as the data it can retrieve. Security does not stop after the deployment. Continuous monitoring is essential. Collect cloud audit logs, VPC flow logs, and the Vertex AI request logs into centralized logging. Feed that telemetry into security command center, and from there create automated incident response workflows. If abnormal data access patterns or privilege escalations occur, automated alerts and the remediation can be triggered immediately. Visibility is one of the strongest security controls you can implement. Now let's bring everything together. This reference architecture combines identity verification, model armor, VPC service controls, sandbox execution, verified software supply chains, protected storage, and continuous monitoring. Every security layer assumes another layer may eventually fail, and this is why defense in depth remains the most effective strategy. No single control secures AI agents, and it is the combination of identity, network, runtime, software supply chain, prompt protection, data security, and observability that creates resilient AI or enterprise AI systems. So, before concluding, here is a practical checklist for implementing secure AI agents. Review and minimize AI permissions. Replace service account keys with workload identity federation. Deploy VPC service controls around Vertex AI, BigQuery, and cloud storage. Enable model armor for prompt filtering and require binary authorization before deployment. Finally, integrate security command center with centralized logging and automated alerts. If your organization follows these 5 steps, you'll already be significantly ahead in securing enterprise AI workloads. Thank you for watching. I hope this session helped you understand why security must become a foundational principle when building enterprise AI agents. If you found this session valuable, feel free to connect with me on LinkedIn, maybe uh, read my technical articles on Medium, subscribe to my YouTube channel, and follow me on social media for more cloud architecture and AI content. If you have questions or ideas for future sessions, I would love to hear from you. Thank you, and I'll see you in the next session.